1987, a man named Gary Hallbrook bought a Ford F-150. Straight six-engine, manual transmission, rubber floor mats. He drove that truck for 28 years. During that time, every repair he ever needed was done by his brother-in-law in a two-car garage with a socket set and a Chilton manual. The most expensive fix was a water pump. It cost him $45 in parts and a Saturday afternoon. Now compare that to the experience of a modern truck owner. You walk onto a dealer lot today and you spend $65,000 on a brand new pickup loaded with cameras, radar, lane assist, and a touchscreen the size of a laptop. 6 months later, someone backs into your front bumper in a park. No structural damage, no frame bend, just a cracked bumper cover. The repair estimate comes back at $6,500. You read it 3 times because you think there has been a mistake. There is no mistake. That is the new normal. In this investigation, we are going to expose why modern truck repairs have become outrageously expensive. We are going to look at the sensor invasion, the software lock, and the calibration racket that has turned every fender bender into a financial catastrophe. The first problem is what the repair industry calls the sensor explosion. Your grandfather's truck had almost no electronics in the bumper. It was a steel bar bolted to the frame. If it got hit, you unbolted it, bolted on a new one, and drove away. That repair took an hour and cost less than $100. Your modern truck has a completely different bumper. Hidden behind that plastic fascia, there are radar sensors for adaptive cruise control, cameras for parking assist, and proximity sensors for automatic braking. Some trucks now have 6 or more individual sensors embedded in the front bumper alone. Each one is wired into the truck's central computer network. When that bumper takes a hit, even a minor one, the damage is no longer cosmetic. Those sensors get knocked out of alignment or cracked internally. Replacing the advanced driver assistance components in a minor front-end collision now averages around $1,500 just for the electronic parts. That is before the bumper itself, before the paint, and before the labor. What used to be a $500 repair now routinely crosses $5,000 because of electronics you cannot see and did not ask for. This was not an accident. This is an engineering choice. The second problem goes deeper than the bumper. Modern trucks are not machines in the way your father understood machines. They are computer networks on wheels. Under the dash, behind the panels, and scattered throughout the frame, there are dozens of electronic control modules running every system in the vehicle. The engine control module manages fuel injection, ignition timing, and emissions. The transmission control module decides when to shift gears. The body control module handles the lights, the locks, the windows, and the alarm system. There is a separate module for the airbags, a separate one for the infotainment system, and often a separate one for the trailer brake controller. Here is the critical difference between old trucks and new ones. On an old truck, if the headlights stopped working, you checked the fuse, checked the bulb, and checked the switch. 3 possible failure points, all of them cheap, all of them mechanical. On a modern truck, the headlights are controlled by the body control module, which communicates with the lighting module over a data network. If a headlight fails, the problem could be the bulb, the wiring, the module, the software, or a data communication error between systems. Diagnosing it requires a $5,000 scan tool and a technician trained in electronic systems. The diagnostic time alone can cost more than the old repair used to cost in total. But diagnosing the problem is only half the battle. Replacing a control module is not like swapping a mechanical part. You cannot just bolt in a new one and drive away. The new module has to be programmed. It has to be electronically paired with every other module in the vehicle using proprietary software that only the dealer has access to. Without that software handshake, the truck will not start. The engine will not run. The transmission will not shift. This is the software lock. Manufacturers have built a system where the physical part is useless without their digital permission. They control the software, so they control the repair. Independent shops are shut out. Your brother-in-law with the socket set is shut out. You are funneled back to the dealership, where labor rates run $180 an hour and the wait list is 3 weeks long. They remove the ability to repair. The third problem is the one that catches most truck owners completely off guard: calibration. Even if you manage to get the parts replaced and the modules programmed, the job is still not finished. Every camera, every radar sensor, and every safety system on the truck has to be recalibrated after the repair. This means the forward-facing camera behind the windshield has to be aimed using laser-guided targets in a controlled environment. The radar in the front bumper has to be aligned to within fractions of a degree. The blind spot sensors in the rear quarter panels have to be tested and verified. If any of these are off by even a small margin, the lane keeping will drift, the automatic braking will trigger at the wrong time, and the adaptive cruise control will misjudge distances. Calibration requires a flat, level shop floor, specialized target boards positioned at exact distances, and a live software connection to the manufacturer's system. The equipment alone can cost a shop $30,000 or more. Many small, independent repair shops simply cannot do it. They do not have the space, the equipment, or the annual software license that manufacturers charge thousands of dollars to maintain. So even a basic collision repair gets subcontracted out to a specialty facility that can perform the calibration, adding more cost, more time, and more hands touching the vehicle. In some rural areas, the nearest calibration-capable shop is over an hour away. The truck has to be towed there, calibrated, and towed back. All of that gets added to the bill. This is why a cracked windshield on a modern truck is no longer a $300 fix. The glass itself might cost $300, but the camera behind it has to be recalibrated, and that calibration can cost another $500 or more. A $300 problem becomes an $800 problem because of a system the driver never interacts with. The most insulting part of this entire system is how the costs compound on small failures. Fleet maintenance data now shows that the biggest drivers of repair expenses are not blown engines or failed transmission. They are small electronic components. A $40 sensor fails and disables an entire system. A wiring issue throws a fault code that puts the truck into limp mode, limiting it to 25 miles per hour until a dealer can plug in and clear the error. A software glitch causes a phantom warning light that takes 3 hours of diagnostic time to track down. Each one of these failures is minor in isolation. None of them would have existed on a truck built 30 years ago. But on a modern truck, they stack up into a relentless pattern that is bleeding owners dry. A truck that averages 3 small electronic failures a year can cost its owner more in maintenance than an old truck cost in a decade. The truck is not weaker. The truck is more complicated, and that complexity is the hidden cost nobody warned you about when you signed the financing papers. The mechanic who used to fix your truck with wrenches and experience now has to be a computer technician, and the labor rates reflect that shift. Shops that invest in the training and diagnostic equipment to work on modern trucks charge accordingly, often between $150 and $200 an hour, just for electronic diagnosis before a single part is replaced. The industry will tell you that these systems make trucks safer, and that is partially true. Automatic braking, lane departure warnings, and blind spot monitoring do prevent accidents, but there is an engineering trade-off that nobody talks about. Every safety feature added to the truck is also a future repair cost added to the truck. Every sensor is a failure point. Every module is a potential $1,200 replacement. Every camera is a calibration bill waiting to happen. They did not add these features because they wanted your truck to last longer. They added them because regulations required them, because marketing demanded them, and because the repair revenue they generate is enormous. A truck that needs $6,500 in electronics work after a parking lot bump is a truck that feeds the parts pipeline, the dealer network, and the software licensing system that manufacturers have built around their vehicles. This is the electronics trap. They sold you a truck wrapped in technology you cannot service, connected to software you cannot access, built with components you cannot replace without their permission. They turned a machine that used to be the most repairable vehicle on the road into a rolling computer that only they can fix. So what do you do about it? First, understand what you are buying. When a dealer shows you a truck loaded with every driver assistance feature available, understand that each one of those features is a future repair liability. The more sensors, the more cameras, the more modules, the higher the repair bills will be for the life of the vehicle. Second, consider simplicity. Some manufacturers still offer work truck packages with fewer electronics, fewer cameras, and fewer systems that need calibration. These trucks are not as flashy. They do not have the giant screens or the 360-degree camera views, but they are cheaper to fix, easier to maintain, and more likely to still be running in 15 years. And third, if you own an older truck that still runs, keep it running. That 2005 Silverado in your driveway with the scratched paint and the manual windows is mechanically superior to a brand new truck when it comes to repairability. Every part on it can be replaced by any shop in the country. No calibration, no software lock, no $180 an hour dealer visit. Do not be seduced by the technology. They are selling you a computer that hauls lumber, and just like a computer, they expect you to replace it when the software becomes obsolete. If you want to see which other products have been engineered the same way, watch the next investigation.